Today we're going to be talking about orbital notation and electron configuration for Reteach Friday 4. So you should have a station handout for this station, and you should be copying down the notes to begin with. Once you're done with the notes, you are going to do the worksheet that is attached to it. For electron configuration and orbital notation, there are 3 rules. The first rule is Aufbau principle. Aufbau is German for building up construction. So we need to fill the lowest orbital first and then make our way up. So in this diagram below, the lowest orbital is the 1s orbital. This means that we need to fill the 1s orbital before we can move up to the next orbital, which in this case would be the 2s orbital. Then we'll move up to 2p, and then until 3s, then to 3p, then 4s, then 3d, and then 4p. So we're going to fill our orbitals in the 1s orbital first, and remember these are our electrons, and then we can move up to the 2s. The next rule is the Pauli exclusion principle. Pauli exclusion says that each box can hold up to 2 electrons. So each one of these boxes can hold up to 2 electrons. And the electrons in those pairs are going to be spinning in opposite directions. So like we talked about in class, electrons are negative, so they're going to want to spin in the opposite direction of each other. We represent this with a up arrow and a down arrow. So again, we represent it with an up arrow and a down arrow. So this is what we want to see in each box. We want to have an up arrow and a down arrow. We do not want to do what's going to be over here with 2 up arrows or 2 down arrows. So we want to make sure that we have 1 up and 1 down, and this is the Pauli exclusion principle. The last rule that we're going to talk about is Hund's rule. Hund's rule says that orbitals, each one of these boxes, needs to get 1 electron first, and then they can actually pair up by getting a second electron. So for example, if I were to fill these boxes down here with electrons, I would need to start at the left, then do another up arrow in the middle, then do another up arrow in the right box. Then once I've filled these 3 arrows, I could go back to the first box over here and put a down arrow, and then the next down arrow, and then the next down arrow. So let me say that again. This is the hardest rule. So we want to start at the left and put 1 up arrow. Then we want to go to the next box and put an up arrow. Then we want to go to the third box and put an up arrow. So we need to go all the way across before we can come back and fill in the down arrows. And this is Hund's rule. The last thing that we're going to look at is a full orbital notation diagram and also electron configuration. So we want to follow the rules that we talked about in class, and we also want to look up the atomic number for the electrons. So the atomic number is going to be the number of electrons that we should be filling our boxes with. So chlorine has 17 electrons, and therefore will have 17 arrows in the boxes due to the atomic number. We want to start at the 1s box, which is Aufbau principle, and we're going to put 1 arrow facing up and 1 arrow facing down, which is the Pauli exclusion principle. Then we're going to fill our next box, so the 2s box, with 1 up arrow. Now we're going to go up to the 2p orbital, and we want to use Hund's rule to go all the way across in the orbitals before we come back to fill them up with down arrows. So we're going to go across, 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 Hund's rule, and then come back and fill in the down arrows. So now I have 2, 4, 6, 8, 10. We're going to go up to 3s, 11, and 12. Then over to 3p, 13, 14, 15. Notice that we're putting them up instead of down because we want to follow the Aufbau principle by building up. We want to follow Pauli exclusion by having up and down arrows in each box. And we want to follow the Hund's rule, which says that we want to go all the way across before pairing up. So now we're going to fill in our last electrons this way. So we have 2, 4, 6, 8, 10, 12, 14, 16, and 17. Now for the electron configuration, or the EC as you see down here, we want to go to the orbital and write down the orbital below. So we put 1s here, and then we count how many electrons are in that box, and there are 2, so the exponent is 2. Then we go up to the next one, which was 2s, and there's 2 electrons in that box, so it becomes 2s2. Then at p's we have 6, so it's 2p6. Then 3s, there's 2 arrows, so it's 3s2. And then lastly in 3p, it's 3p5, so we put 3p5 on the bottom. This entire thing is the electron configuration. Notice that we put them in the same order as we traveled up the ladder with Appbaugh principle. And then lastly, we want to make sure that all the exponents, or the little numbers in the back, add up to the total atomic number, which in this case 2 plus 2 plus 6 plus 2 plus 5 is 17 electrons. Now you're going to go ahead and complete your worksheet and raise your hand if you have any questions.